one step at a time.
Yeah,
Minus
mg.
m of a balloon times g equals, ready?
Okay, one question. Why don't you have the cold air, like the force of cold air? Or is that just...
That's the buoyant force.
Yeah, but it's going up. There's...
Buoyant force is always up.
Okay. Alright.
I mean, have I ever drawn buoyant force down?
No.
Okay. M balloon A. It's not 0. If it were just floating and not moving in the y direction, what would I write on the right hand side there? 0. But it is. It says it's accelerating, correct? All right, check it out. Okay, Amanda, here we go. How do I get the buoyant force? Ready?
Rho times volume.
Rho of what?
Fluid.
Which
Air.
fluid?
Air.
Which one?
Hot
Air.
air. No.
You have to be hot air.
Nope.
Cold air?
It's the which fluid's being pushed aside?
Cold air.
Cold air. That's the one you want here. Got it?
Yeah.
What is the object that is pushing the air aside? Volume of that. What do I call it? The balloon. So volume of balloon. So rho times v times g. That's the buoyant force.
Yeah.
Now, how much does the balloon weigh?
Nothing.
It's not 0.
It doesn't tell you. It says ignore the balloon fabric and basket.
So they want you to account for the
Consider
mass of
weight
the air.
to only be hot air.
Correct. They want you to account for the mass of the air. How do I get it? The hot air.
Is rho times volume
Rho of what?
of hot air.
Times the volume of what?
The balloon.
Good. Times g equals. What goes over here?
Hot air times volume.
Of what?
Balloon.
Balloon times A.
Yeah.
Did we need to know the volume of the balloon? No, it cancels, right? Check it out. So it turns out the acceleration, this number, is going to be rho CAG minus rho HAG over rho HA.
Wouldn't the rho of HA just cancel out?
No, it has to be in each term on top for it to cancel. But what is true is that the units of the densities cancel. So notice I get g times some number will give me the acceleration, which seems reasonable. How many people got a number now that we've seen it? Eric?
I got 3.79.
3.79-ish or something? Yeah. Right. So I want you to think about this. If I have a beach ball and I push it underwater and then I let go, at the instant I let go, what are the forces acting on it? Buoyant force and weight, correct? Is the weight of the beach ball going to exceed the buoyant force? No, we know it isn't. The thing fires and it accelerates, right? Upward. So, you guys listen to this. This is also fascinating. You can tell all your friends. How many people have been rafting? Just like half of you whitewater rafting? What do you wear when you raft, or you should wear when you raft? A personal flotation device. What's it typically made of?
Air.
Large, lightweight material. Why?
Can float.
So it pushes aside more fluid to add more buoyant force to you without adding more weight to you. Does that Makes sense. Okay? A personal flotation device pushes aside more water, thus giving you a greater buoyant force without making you heavier or that much heavier. And how do you get someone out of the water easily?
Push them
Anybody know
down.
the technique?
Push them down.
Say it again.
Push them down.
Push them under. Not all the way, but you know, a little bit. You push them under because then more of their volume is underwater, which makes the buoyant force bigger, and then you yank them out as they're coming up. It just makes it that much easier. You push them down, you get a bigger buoyant force. As they accelerate, you lift them out into the boat.
So you
It's
mean,
all about Archimedes' principle.
you mean it's not easy to kill somebody under the water?
It's not easy to drown someone in a PFD.
Good to know.
That was her thought, not mine. That was her thought. I'm not taking credit for that one. Questions about this problem? Or any of these problems? Taylor?
I just have a question in general. So how come like when